Alright, let's start talking about topic 2.4. We have slopes of parallel and perpendicular lines today. Before we start that, this is going to be your bell work when you come into class Monday or Tuesday. And we're working together to create a presentation. We've done that already. It covers the concept that your group has been assigned, and one example for each person in your group who's not the speaker. Your speaker is teaching the concept while everyone else is writing their problem on the board or wherever they're going to present it, and they are checking to make sure everyone understands, and they should, from this video and the great presentations that we had last week. I don't doubt that we're going to continue to be successful in this approach. But while you're setting up your presentation, I'm going to be coming from pod to pod after the first 10 or 15 minutes, checking on your notes to make sure you watch this video, answer any questions you have, ask what your problems are going to be on the board so we can start talking about them, make sure that they are appropriate and fully cover the content. I need to know who's going up to speak, and I need to know who's going to be doing the presentation's problems. While I'm doing that, I also want to see all of your notes from this video. You'll notice I have the presentation topics and the pods covered up right now. So I don't want you knowing ahead of time, because I did notice a lot of the notes only focused on your pod number, and you were great with those. But when we started doing the homework, I got a lot of questions from the ones you weren't the expert on. Come in fully prepared to be the expert on any of these topics in this video. Work efficiently, and we will continue to do the homework after presentations. That worked out great. I had so many good questions. I heard so much more great conversation than I normally hear when we just do participation. I think it's because you guys know if you get it done in class, you don't have anything to do at home. Just in general, the conversation was much more in depth. I heard people explaining every step in detail to each other. I heard people questioning why they did certain things. I had people with the same answers with different steps to get to those answers who were discussing their answers and methods with each other, so it worked out great. And I'd like to see that continue as we go on. So let's go on. So we're going to do a little Algebra 1 review here really quick, and we're going to make sure that we understand exactly what a slope is, how to put stuff in slope-intercept form, and all that before we move on. I did kind of assume that we were all good for graphing from Algebra 1 when we did our tests for topic 1. And a lot of people make a lot of silly mistakes, and when I pointed them out after the test, they're like, oh, I knew that, it's been so long. So I want to cover this before we move forward. Don't want to double up on those mistakes. So a hill and a gondola lying 20 feet above the ground that goes up the hill both have slope 1/2. So for every foot they go to the right, as you'll see in the diagram, they move up 1/2 of a foot. What is the geometric relationship between the hill and the gondola line? So here are two lines. This is the hill. These are the support beams for the gondola line. If you're like me, never seen snow in your life, and definitely never seen anything like this before, think of the sky ride at Busch Gardens. The major difference being that Florida is so flat, it would be more of a corresponding line with the x-axis, but the towers would all be the same. The sky rides are supported from the same height except for at the exchanges. So, but these are moving up. For every foot, they're moving up 1/2 a foot. Over a foot, go up 1/2 a foot. Over a foot, go up 1/2 a foot. So that's our model, that's our picture, that's everything we've asked for so far. What are the y-intercepts of the two lines? So what I'm going to do is move this picture over really quick so we can bounce back and forth and make sure that we're talking about it and showing it at the same time. So the question is, what are the y-intercepts of the two lines? So if I want to find the y-intercepts, some things I need to know. Where's my pen? Oh, tablet shut off. Okay, so the first thing I need to know is, what is a y-intercept? The y-intercept is where the line crosses the y-axis. The y-axis is this vertical axis right here. This is our y-axis. So we're looking for the point where the line touches the y-axis. So our first, the hills line is right here at 0, and the gondola line is at 20. So we can say that our y-intercept here is 20. and our y-intercept here is 0. Now let's go back to our next question. So we found the y-intercepts from the information provided. So we're going to look at the word problem and the y-intercepts of the two lines that we found. What expressions model these two lines? So let's go back to this, and now I'm going to call this line 1, and this is going to be our line 2. I'm going to change colors, and we're going to look at line 1. So to find the expression that generates line 1, we're going to use point-intercept form, and that is y equals mx plus b. And let's talk about this really quick. This is our dependent variable. And that means the value of this variable depends on our independent variable. If you want to think about it in terms of slope, we can pick, as our x moves along, for any of these marks, I can move up to the line. I'm going to use line 2. So this is independent because it can be any of these lines. Wherever I move up from, when I intersect the line, I go to the y-axis. Whatever this value is my value for y in here. And that's why this is called the dependent variable. It depends on what your x value is. So let's put that back. My b in this format is always the y-intercept every time. And the reason that is because, like I said here, our x value is 0, and this is our y value. So if I were to make x equals 0, then our slope times 0 will always be 0. So we won't have anything here, and we'll just have y equals b. This is why it is always the y-intercept. Now, m is our slope. We use m for slope. So with these 4 pieces of information, we can start constructing an expression to model this line. So we know that y is our dependent variable, so we're going to go ahead and leave it as y. It's going to depend on what x is. Then our slope on the word problem was defined as 1/2. So I'm going to replace my m with 1/2. X is my independent variable, so as x changes, we'll find out what y is. So I'm going to leave this as x. And on this line, my y-intercept, I said, was 20. So I am going to put it there for 20. Now, if you want to see what I meant earlier by if I make x 0, this will cancel out, and we'll just get y equals 20. So I'm going to do a t-table. I'm just going to choose x is 0. That means I haven't left. I am sitting right here on the x line, and I'm trying to, I haven't gone right, I haven't gone left. I'm going to see how high up I have to go. So if I plug in 0 here, I get 1/2 times 0 plus 20 is equal to 20. So that does verify that I have my y-intercept correct. So let's go look at line 2, put it in a new color. So line 2, we know we're going to have our dependent variable. We know for a fact that we have our slope to be 1/2. We're going to have our independent variable. Now, our y-intercept is 0 because it crosses right at x equals 0. So it hits y is 0 as well. So I'm going to have plus 0. Now, the addition identity says anything plus 0 is still the same number. So I'm just going to rewrite this as y equals 1/2 x. So the two lines I have, line 2 is y equals 1/2 x. And line 1 equals y equals 1/2 x plus 20. So let's go back over and see if there's any more questions on the PowerPoint. Alright, so let's analyze the two expressions we just created and determine if they will ever intersect. Justify your reasoning. This is geometry. Everything we do, we have to justify it. So let's see if there's anything else. When you answer this, this is going, the analyze the expressions created. This goes on your participation sheet. This is one of the things I'm going to check to make sure you watch the video and you kind of get the idea here. Now, if you're wrong, that's fine. We're going to talk about it in class. We're going to talk about it more in the video. Don't worry about it being wrong. I want to see your thought process before you get a thorough introduction to this topic and before you really start practicing on your own. I just want to know, analyzing the expressions, y equals 1/2 x and y equals 1/2 x plus 20, determine if those lines will ever intersect. And if they If you say they will intersect at some point, you must justify it with a theorem we learned in class. And if you say they will not, you must also justify it with a theorem we learned in class. So one last chance to look at them. Our slope is 1/2 for both of them. Our y-intercepts differ. So I'm looking forward to seeing what you think. Now we're going to go into theorem 213. We used inductive reasoning last week on Friday in class to show this theorem basically, but now we're going to actually formalize it. We're giving it a name. It's not an exciting name. It's just theorem 213. But what it's saying is if P and Q are both not vertical, so they're not vertical as we see here, straight up and down, or with an undefined slope, then P is parallel to Q if and only if the slope of line P equals the slope of line Q. So if you go back to that problem I just gave you, we're starting to see some theorems that are going to give us guidance on answering that question. And this one says if P and Q are both vertical, then P is parallel to Q. Now you notice here it doesn't say anything about the slope because the slope's undefined. So they both have the same undefined slope. They are vertical, and by this theorem they are parallel. So let's look at one in practice. Now I have this up. You're going to have the points. So this actually looks like one of the theorems we did in class, the point through a line theorem that we did on Friday. And then let me get it on the other side. Do not enlarge. Okay, so what we're going to ask on the screen here is, using theorem 213, determine if these lines are parallel. And then I have a bonus question. This goes on your participation sheet. I'd like to see what you think about this. Can you find a second unique line, meaning not the same line we already found? So the yellow line, we're not going to find that one again. We have to find another unique line that passes through the point 5, 4 that is also parallel to the blue line y equals 2x plus 1. Justify your answer using theorems in class. I'm really looking forward to seeing these answers. You guys did so well on it on Friday. I think it's going to be impressive. I have no doubt about it. So let's switch back over and look at this graph. Now this is not the full formal way we're going to do it, but this is one way just to quickly verify that lines are parallel. We're going to do rise over run, which is our change in y over our change in x. So it seems like every time I delete my thing and start a new one, I get the small thin pen again, but let's see. So I'm going to find points that intersect along the grid, that are right on the grid's intersection point. So there's one, and here's one. I'm going to do that again here. So my y-intercept, I don't even have to do anything. I don't look at this. I automatically see plus y equals 2x plus 1. I automatically know if I make this 0, this is going to cancel. I'm going to get y equals 1. So that's a definite point for me. And then I'm going to come here, and this crosses here. So I have 2 points on each of these lines. So now I'm going to determine their slope. And the way I'm going to determine their slope is I'm going to see how many times do I have to go up to get to the next point. So 2 up and 1 to the right. So my rise is 2 and my run is 1. So rise over 1 is 2 over 1. So that means my slope is equal to 2 over 1, which is just equal to 2. If you look at this, you can see that our original slope was 2x, so our slope was 2 because m is substituted for 2, or 2 is substituted for m. So right now I have a slope of 2 for the blue line, and by theorem 213, if we have the exact same slope for both of these lines, they are parallel. So I'm going to go to the yellow line, and I'm going to go up 1, I'm going to go up 2, I'm going to go over 1. So this gives me 2 up, up being the positive direction, and 1 to the right, right being the positive direction. I have again 2 over 1 is equal to m, m is equal to 2. Now, I'm only showing you in the positive direction, so let's look at this again in the negative direction. And what I mean by the negative direction is I'm going to start at the point on the top and then work back down to the point on the left. So I'm going to go 1 down, 2 down, so that's negative 2, because going down on y, anything below the x-axis is negative. As I head down, that's true still, So I went down 2, or I moved -2 in y, so my change is y, in y is -2. And then I went left 1. Going left is negative, so I'm going to end up with -2 over -1, which is equal to 2. Slopes are still checking out to be 2. So I think we're making a pretty good case here that these lines are parallel. I'm going to go down 1, I'm going to go down 2, that's -2 again. And I'm going to go left 1, that's -1. So I'm going to have -2 over -1. And again, we found the slope to be 2. That is the worst circling of 2 numbers I've ever seen. Yep, so our slope for both of these lines is definitely 2. Since the slopes are equal, these lines are in fact parallel. So what I'm looking forward to now is, can you find a second line that runs through this 0.54? It's 0.54 right here. That's also parallel to the blue line. I think we're going to have a good time with this one. I'm looking forward to seeing what you guys find. So our next thing is finding the slope of lines from points. So the way I just showed you is not how you're going to do it on your test, because you can't show me any proof by just looking at a picture. That's how you're going to check your work. If you really want to make sure you did well on the quiz or test, you're going to use finding the slopes of lines from points. Then you're going to go back and look at the graph, or you're going to graph those 2 points and find their slope. So I showed you how to check your work first. Now I'm going to show you how to actually do your work. And then you're going to be fully equipped to work with parallel lines. Perpendicular lines have a few extra rules, so we're going to do those next. So, finding the slope of lines from points. This is an Algebra 1 topic again, but we're definitely going to revisit it because we're going to need this throughout the year now. So, again, I already said it, but M always denotes slope. Slope can be denoted as rise over run, but a little bit more mathematically, it's the change in the y values over the change in the x values. So we can find the slope of a line by finding the change in the y values divided by the change in the x values. So if I have 2 points, I can take the second y value and subtract the first y value, and then I can take the second x value and subtract the first x value, and I will end up with the slope. So let's actually see that happen. Find the slope of the line passing through the points -1, 2. Oh, -1, -2. That was another big mistake on the quiz, which I totally understand. People were forgetting and dropping negative signs when they were doing their ordered pairs. It's going to be a little bit more careful on this one. We still have 2 tests if you didn't do well on the first test to help you bring your grade up. And I'm looking forward to hosting you for test corrections. So I know that my formula is going to be y2 minus y1 over x2 minus x1. So I'm going to go back up here. I'm going to label these just to be 100% safe. Here's my x1. Here's my x2. Here's my y1. Because this is an ordered pair, and ordered pairs are always in the form xy. And this is my first ordered pair, so they get denoted with the 1s. Here's my second ordered pair, so we're going to denote that with 2s. And then I'm going to plug them in. Actually, I'm going to increase my brush size. So y2 is 4. And then I'm going to do minus. Now this is where we have to be careful. y1 is -2. So make sure you copy it as -2. Over. And I'm going to have x2. So I'm going to have 1 minus. Now be careful. -1. If you omit this negative sign, you're going to end up dividing by 0, and you're going to have an undefined slope. That's fine. We can do that in these, but right now, let's not complicate it. Let's make sure that we're carrying over our negative signs when doing this. Now I can look at this and I know that 2 negatives becomes a positive, so this is really going to be the same as 4 plus 2, which gives me 6. And here I have the same thing as 1 plus 1, which is going to give me 2. So I have a slope of 3, or my slope is, well, I was going to write the word 3. Let's just put a number. So the most important thing is to always pay attention to your signs. We're fortunate that we have classes that are on block schedule. We have an hour and a half. Don't finish your test as quickly as you can just to sit there and read a book or doodle. Finish your test and review your answers. Double check your signs. Make sure you didn't have any errors. Partial credit's nice. I do give partial credit, but full credit's always nicer. So keep that in mind and be very careful with your signs. Right now, I'm anticipating that these signs, when we have a double negative, or anytime we have a negative in our ordered pair, I'm anticipating that to be kind of the part where we make mistakes, because we've been doing so great at everything else we've done in this topic. So there has to be a catch, right? There always has to be a catch. So let me double check that I'm on the right screen. Yeah, I've been on the right screen. So let's go back to the other screen now and look at theorem 214. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. That's a little bit confusing sounding. But let's look at the vertical line part first and a horizontal line, the second part of the theorem, and then we're going to go back and look at the first part in a little bit more depth. A vertical line and a horizontal line are perpendicular to each other. We have to make that distinction because you can't multiply undefined by 0 to get -1. And that's why earlier we also couldn't say that our slope is undefined. We just understand it to be undefined because we can't divide by 0, but we can't actually do any operations with that. So a horizontal and a vertical line by definition are perpendicular. Now we have our other example. Let's go back on the left. If P and Q are both not vertical, so that means they're not undefined slope, then P is parallel to Q if and only if the product of their slopes is -1. What does that mean? The product of their slopes being -1 means anything that's in my y equals mx plus b. If I have line 1 to be y equals mx plus b, and line 2 y equals mx. Oh, I wanted to go back to green. Well, that's even more confusing. Come on, buddy. So if I take my teal M times my green M, which I said those backwards, but their product should be -1 if the lines are perpendicular. Let's see that played out with some numbers. I think this is one that in the general form is much more confusing than it actually needs to be. If we just plug in some numbers here for M, it's so much easier, and I think you're going to really appreciate it. But just remember that line 1, the slope of line 1 times the slope of line 2 must equal -1 for lines to be perpendicular. This is the sign for perpendicular. It's kind of like an upside down capital T. You can also see it on the other screen where it's that the conclusion is then P is perpendicular to Q. So let's look at it with numbers. So I have a graph up on the screen. We're going to make a few determinations, and then we're going to switch back over to the screen in which I draw on, and we're going to go from there to find out if these lines are in fact perpendicular. They look perpendicular, but we do nothing by inspection in this class. We have to show everything. So let's make the blue line, we'll just call it line blue, and line red. Let's find some points on line blue and see if we can determine the slope. So, looking at line blue, it definitely has the point 0, 0 as well as line red. So I'm going to go ahead and put those down on the other screen, and then once we get all this sorted out, we'll switch over to the other screen. Now I'm going to look for another point where it definitely crosses, and I can see here it looks like at the point x equals 1 and y equals 2 it also crosses, and that's my red line, so I'm going to record the point 1, 2 as well. Then on my blue line it looks like I can go to -2 since I'm going to the left from the origin. It is negative, and then I'm going in a positive direction up, so 2 to the left is negative, so I have a -2 in my denominator, and then I go up 1, which is positive, so I'm going to end up with -1/2 for my slope. This is a prediction. But my point, my point was to find the point, and the point is -2, 1. So I'm going to switch over to a blue, and we're going to work on line blue. So I know that I need my change in y, so y2 minus y1 over x2 minus x1 is my slope. So I'm going to relabel them. Always relabel them, no matter how confident you are, no matter how comfortable you are. Always label them, especially when there's a score involved. Simple. Developing good habits now will help you prevent simple mistakes later. And you may not feel pressure on this test, but it's been a long time since I sat down for an EOC style test. I don't want you to feel like you've forgotten something, so if you get in the habit of doing it now, it's just good practice. It'll help you be confident and comfortable when you're taking the test. So my y2 is 1, so I'm going to have 1 minus 0. And my x2 is negative 2. I'm going to have that minus 0, because that's my y1. So it looks like I'm going to end up with 1 over negative 2. So that is my slope. That was also my prediction. So I did it backwards. I called it a prediction, not checking my work, because I went ahead and, out of habit, just like I said, try and develop good habits now, I went ahead and while I was finding the point, I determined the slope ahead of time that I should find if it's correct. I know that counting it is simple. It's hard to make a mistake doing that. I'm more likely to make sign error mistakes while I'm writing these problems down or solving them. So I didn't say I checked my work. I made a prediction, and I've seen that with the math, my prediction is right. Now, you might say, but Mr. Fimble, on yours prediction, you have negative 1 over 2, positive 2, and on your result, you have 1 over negative 2. Those are the same thing. Those are still both negative 1/2. So my prediction worked out to be exactly what I found my slope to be. So I can confidently say that the slope of my blue line is negative 1/2. And if you have trouble seeing the negative sign, think of it, if I were to pull the negative out, I have negative 1/2. So now let's look at my red line. My red line gives me, see, I'm starting to think these may not be the same slope because I have a sign difference. And I have swapped, my x is my y here, x here, y here, and then my sign swapped, and I have at y and y. Now, I know something you don't quite know yet, and I tried to get you to think about it when I said I'm worried that we're not going to have the same slope, but we're not shooting for the same slope anymore, are we? We're looking at perpendicular lines, and perpendicular lines can't have the same slope, because if they had the same slope, they would be parallel and they would never intersect, much less at the special definition of a perpendicular line, which means they intersect at 90 degrees. So let's do our change in y. So I'm not going to rewrite the formula. We have it right here, or the equation, sorry. But I am going to say that this is x1, this is y1, developing the good habits. This kind of looks like a apathetic student who doesn't want to write this every time. But for success, we're going to concentrate on writing this down every time. Remember, a happy grader is a lenient grader. If I see you're doing this and you make a mistake, I'll at least know that you've identified your x1 and y1 and x2 and y2 properly. And I may just make a note that says, hey, be careful. I did that in a couple of your tests for the midpoint formula and distance formula. And instead of taking off, I took off a little bit less for you. Even though you made the mistake, if I was able to follow the method and you did it right, I still gave you a little bit more than just half credit. So keep that in mind. If I see that you're practicing good habits but you still make a mistake, that's okay, you're developing. We're going to keep practicing these good habits so that they become second nature at the end of this school year. So I'm going to do y2 minus y1 over x2 minus x1. This is going to give me 2 over 1, which is going to give me 2, so my slope is 2. Now, the definition of perpendicular lines, let's put it in purple. I haven't used purple on this page yet. By definition, perpendicular lines have, let's say, oh, that's a T. Their slopes have a product of -1. So that means if I take my blue slope, boy, it would be nice if I could remember the order of these buttons. Alright, So all that's saying is, I'm going to scroll down a little bit. If I take my blue slope and make it 1/2, I'm going to end up doing m times my red slope, m, and my red slope is 2. I should get -1 if these are perpendicular lines. So anytime I multiply fractions, again, develop good habits now, because even in Algebra 2 and even later on at the University of Tampa when I was tutoring students, they always ask me, do we cross multiply or do we multiply straight across? These aren't proportions, so we're multiplying straight across. So let's just be clear for ourselves for no confusion. Let's put this denominator here so that I can go straight across. And straight across. So -1 times 2 is... I've gotten so used to you guys just always helping me out and answering. I just paused waiting for an answer. And then 2 times 1 is 2. This simplifies to -1. By theorem 213, so, or 1214, sorry, 214. By theorem 214, we have shown that for the two lines, or the 2 points that we were given, their product of their slopes is -1. And we can therefore say, so therefore, let's do L red and L blue are perpendicular. That's how perpendicular lines work. A lot more steps than parallel. Parallel, we just verify that they have the same slope. Truthfully, the y-intercept doesn't matter too much because they're never going to intersect, but we still have to show that they are by theorem 213. So 214 is just more involved than 213, but we are on the right track to do this. So I definitely have another example for you. This one's going to be a little bit different. Might look a little harder at first, but I don't think it is. So I'm going to zoom back in over here. That's the one we just did. We showed that's perpendicular. It was nice to have an introductory one where we went through the origin, because 0, 0, we're just subtracting 0 or subtracting from 0 a bunch of times, and that keeps it really easy for us. But now we're going to have this line goes through 0, 0, but this line never touches the origin, but it has a y-intercept at 6, and it has an x-intercept at -4. So we can use those points if we want to involve more zeros into it. I think that might not be a bad idea. We also can just find the slope and make a prediction, which is what I honestly would do. I would go ahead and make a prediction on what they're going to be, then do the math, and instead of checking my answer, just verify my prediction. If I get a slope by the math that is not my prediction, double checking my math, and if I get the same thing again, double check my signs, all of that, I'm going to go back to the graph and double check my prediction and see if maybe I went up, a few times but counted it as negative, or if I confused left as positive when in left is actually negative. But at least there I have a safety net, and I'm always going to want safety nets. So what I want to do here is I have line red and line blue again. So I'm going to go ahead and set this problem up. Oh, that's the eraser. So line red. It'd be nice if I wrote these in red. Line red. I'm just going to use L1 for line red because it's in red. And I'm going to use L2 for blue since it's in blue. L1 has, let's find 2 points on L1. So I'm going to say -4 because I went left 4 on the x-axis, so that's -4. And the y-axis I didn't move up or down on, so I'm going to say that's 0. So I'm starting with -4, 0. And then I'm going to look at another point where it clearly passes through. So I'm going to go up 1, check, it didn't go. Up 2, check, we're not there. Up 3, and then I'm at 3. So now I'm going to look at this point. What is this point? This point is -2, 3. So I'm going to go back here. I'm going to write -2, 3. And the reason I did that instead of going up here is it's just a quicker route to finding the slope. So if I start here and I go up 1, 2, 3, and then I go right 1, 2, My rise was 3 in the positive direction, and my run was 2 in the positive direction. So my prediction is that I am going up 3 and over 2. So I'm predicting that this is going to be my slope. I'm going to verify that. This doesn't count in this class. You can't do it. In Algebra 1, sometimes you might be able to sneak it by. That's understandable. But we're going to be proving things with theorems, and we have to show it using math and supporting it with mathematics. So the next thing we're going to do, well, let's go ahead and just do all of the red line, then we'll do all of the blue line, and then we'll make our final conclusion. So if I want the change in y, so y2 minus y1 over x2 minus x1, and that's going to give me my slope for red. I'm going to keep developing this good habit and say y1 x1, x2 y2, and then I'm going to plug them in. So y2 is 3, y1 is 0. So we got lucky there that we chose a point that has a 0 value for y. And then my x2 is negative 2. And now I'm going to do minus. I'm not going to look at my other x value yet. I don't want to know if it's positive or negative. I'm going to get in the habit of always writing minus in parentheses. If this is a positive number, we can drop the parentheses because it's going to be minus. If it's not a positive number, let's start getting in the habit of, well, x1, that is negative 4. So now we can clearly see what we're going to end up with is 3 minus 0 and negative 2 plus, because these are going to distribute in turns of plus, so it's going to be negative 2 plus 4, which is going to give me 3 over 2. Convenient? No, I'm not going to say conveniently. It's not convenient. We have shown that our prediction is correct. Our slope is 3 over 2. I'm going to go ahead and circle this so I can come back to it quickly, because I seem to get lost every once in a while. So, and on the test or quiz, I'm going to want to see, you know, your steps in between circled and then your final answer boxed in. So my line 2, conveniently, my first point is 0, 0. And my second point, if I go from 0, 0, I'm going to follow the line, and it looks like right here, I am at negative 3, positive 2. So first I'm going to write the point, negative 3, positive 2. Now I'm going to make a prediction. I had to go, my run was negative 3 and my rise was positive 2. So if my run is negative 3 and my rise is positive 2, that's my prediction for my slope. Now, I will admit, since I am looking for a perpendicular line, I will look at these really quick and just see if they check out. And they do, because 3 times 2 is 6 and 3 times 2 is 6. So if I have 6 over 6, I get 1. But I only have one negative number, so it looks like I'm on the right track. But I can't just say I'm done. But my prediction in blue is not good enough. I now have to show it. So I already have the formula written here, so I'm going to apply that. But this is my x1, this is my y1, this is my x2, this is my y2. So I'm going to have y2, which is 2, minus 0 over x2, which is negative 3 minus 0. And I get 2 over negative 3. So now I'm going to do my slopes. I'm going to multiply them together to verify, because we can't just trust it. We have to show it. I'm going to show that these do in fact multiply to be negative 1. So I'm going to have 3 over 2, and I'm going to have negative 2 over 3. We're multiplying, it's not a proportion, so we're fortunate in the fact that we can just go straight across. So 3 times 2 is 6. 3 times 2 is 6. And we have our negative sign. And we only have one of them, so we're going to have negative 6 over 6, which is negative 1. We have shown that these lines are in fact perpendicular. This one was a little bit more likely to cause confusion, even though sometimes dealing with 0, 0, and double negatives very easily causes confusion as well. But we're just going to stick with this just like that. Please, please, please label everything like I said. It makes everything so much easier on you. It makes it it'll also help you feel more confident when you're checking everything. Y is equal to 3x minus 5, and line 2, our slope intercept form is y equals 6 over 2 x plus 1. So I'm just going to write down, right now I'm just trying to figure out if they're parallel, perpendicular, or neither. I'm not going to worry about my y-intercepts right now. I just want to look at my slopes, and I want to make a determination on whether or not they're parallel, perpendicular, or neither, based only off the slopes. That's very important to keep in mind here. So my line 1 has a slope of 3x, and my line 2 has a slope of 6 over 2x. Well, this simplifies to 3 over 1, which again simplifies to 3x. 3x is equal to 3x. Therefore, these lines for number 1 are parallel. So let's look at line 2. I have... Alright, this is one that when I was showing it to my daughter, she was like, "Dad, this isn't fair. How am I supposed to always remember this?" Now, she doesn't always remember. These are our two. This is our both of our equations, right? So if I were to look at this in y equals mx plus b form, I don't have a b value. There's no plus anything here or plus anything here. So I know my y-intercept is automatically 0, so that's easy. Then this is where my daughter complains that I would give her a problem like this to think about. There's no m here, according to her. Now, you're at home watching this video and we're saying, yeah, well, we do know that there's always an understood 1. So, we can now say that the product of our slopes are 1 times -1, which is -1. So these are definitely perpendicular. So pay attention to that. Keep that on mind. I don't want you to get on the quiz and think, oh, this is a trick question. He didn't give us a number, so we're going to say neither. It's definitely not. Always multiply the two slopes or the two m values and see if you get -1. If you do, they're perpendicular. If they're exactly the same, so if this had just been y equals x and y equals x, they'd be parallel. And if this was y equals x and this was y equals -2x, they would be neither. Alright, let's look at the next one. So, I guess this is another one that she would complain about. So I have, line 1 is 2/3 x. So my m value, I'm going to do this one in a different color. My m value is 2/3, that's my slope for line 1. And then my line 2, I have 3/2. So I've already noticed the reciprocals, and I've noticed on the problems where we did perpendicular lines, they were definitely reciprocals, but there's one thing that's missing. I can multiply these together. See, as I have 2/3 and 3/2. If I multiply them together, I get 6 here, and I get 6 here, which gives me 1. 1 does not equal -1. These are neither parallel nor perpendicular, because that product is not -1. It is strictly, it is 1, not -1. So I multiply them together, they're 1, but that's not -1. Don't make that mistake. Let's look at the next one. 11 over 8 x, so that's my m value is 11 over 8. So line 1, I have 11 over 8, and line 2, I have 44 over 32. So I'm going to look at these. They're both positive. So I already know I'm not going to even consider perpendicular right now. I'm looking at either neither or parallel. What I have to consider is, are these fractions equivalent, and can I simplify them to be in the exact same form? And the answer is yes. I can look here. I can see that 44 divided by 11. Oh, sorry. I gave you the answer. 44 divided by 4 and 32 divided by 4 will simplify to 11 over 8. 11 over 8 is equal to 11 over 8. So, and these are both equal to my m. Therefore, line 1 and line 2 are parallel. I am going to leave the last 2 for you. I want to see them on your participation sheet. Remember that parallel lines are exactly equivalent. They're not close enough, and we do not round, because no matter how minuscule the difference in their slope is, at some point along their travels they have to intersect with each other. They have to have exactly the same slope value for them to be parallel. Notice the video totally changed. This is a testament to paying attention to exactly what you're doing. I copied the problem wrong, so I'm going to redo it because the numbers I used made it a little bit more complicated than I want to show you right now. So let's look at this again. I'm going to recopy the expression on the other window, y equals negative x plus 7. And this time I'm going to copy the right points. I have positive 7, negative 2. What I'm trying to find is a line that is parallel to this equation that passes through this point. So parallel means I need the exact same slope. Well, we already determined in this format, y equals mx plus b, that our slope is negative 1 because there's an understood 1 there. So I'm going to say that my m is equal to negative 1. So this is my original. My new equation, we're going to do in a dark blue. I'm going to rewrite this equation, and I'm going to start plugging in everything I know. So I'm going to have negative 1 because it's parallel, it has to go through the same point. Now we have 3 variables left over. We have y, which is our dependent variable, x, which is our independent variable, and we have our b value, which is our y-intercept. So if I have a line that is parallel, all I need to figure out now to make sure it passes through the point given is that I find the correct y-intercept. So I'm going to maintain b as my y-intercept, and what these problems do that is very fortunate for us is our y value can be plugged in here, and our x value can be plugged in right here. So what I'm going to end up with for my new equation is negative 2 equals negative 1 times 7, y times 7, because my x value is 7, and I have my slope times my independent variable plus b. This is already looking much nicer than it was when we started. Negative 2 is equal to negative 7 plus b. Add 7 to both sides, and I get 5 is equal to b. So when I write my new equation, I'm going to have y, my dependent variable, is equal to, my slope doesn't change because they're parallel, so I'm definitely going to have negative 1. But what will change is my independent variable. I'm not going to write the 1, we know it's understood. And then my new b is going to go here, so I'm going to have plus 5. My 5s look like b's with hats. Alright, so that is all we have to do to find a point that is parallel to a line that passes through another point. So your question at the very beginning of this video, that bonus question, can you find another line that passes through 7, negative 2 that is also parallel to our original equation? Same answer you should have gotten at the beginning is the same answer you'll get to that now. I'm not going to give it away, but if you have this topic, I'd like for you to at least mention it and kind of discuss whether or not it's possible to find another line. So let's just say that this is, I'm going to do it in red since I wrote it in red here. Say that this is, oh, definitely showing red up there. I'm going to do it in red. It's a negative slope. We're going to say that this point is 7. That's our y-intercept. And then our other one is negative x plus 5. That's in blue, buddy. Alright, so we're going to put blue. We're going to say that this point is 5, or 0, 5 to be more accurate. And this would be 0, 7. Can we find another point that passes through 7, negative 2? Which is right here. This is that point we were looking for. Can we find another line that's parallel to the red line that passes through here that is not this blue line? We needed a third line, a unique line. So let's say we're going to use the color orange. Can you find an orange line that is parallel to the red line, that passes through this point, but is not the same as the blue line. Good luck if you can do it. I am looking forward to your answer. If you cannot do it, I am looking forward to your answer. So let's look at the next thing. And I think it's pretty logical that we're going to find an equation for a line perpendicular to an equation. So we're going to start. I'm going to go ahead and fill in the board over here. Oh, make that my main screen of focus. Y equals mx plus b. I'm always going to write that down. We're going to see it and see it and see it so we never forget it. I know that my m is 3. I know that my y-intercept right now doesn't matter, so I'm not going to worry about it. What I need to know is, let's switch over. I'm looking for perpendicular lines, meaning that m1 times m2, let's call this m1 since we know it's 3, is equal to -1. So I have to find a number that when I multiply it by 3, I get -1. So I can do this, and I can do this, and I can get x equals -1/3. So now I know that my second line needs to have a slope of -1/3. This is enough proof. You don't have to plug this back in. You can. 3 times -1/3 is definitely -1, but that's how you find your opposite reciprocal slope. You just plug in, you take your original slope and you do it 3 times a variable is equal to -1, and that gives you the reciprocal slope. So I'm going to say that my m2 must be -1/3. Now, the question said it passes through the point -9, -2. So what I need here is a line that will land me on the point -9, -2, and will also be perpendicular to my original line. Don't let this one be daunting or overwhelming. Sorry, I started speaking slower to give it this air of complexity, but it's definitely not. So our new line is going to be in the form y equals mx plus b. We know what our x is. We know what our y is. We know what our x is, sorry, not this one. We're going to know what our m2 is. This is our new line we're making. So the only thing we don't know is this b, so that's going to remain our variable. And what we're going to end up with is -2 is equal to -1/3 times -9 plus b. So, very easy. Again, develop the good habits now. 9/1, straight across. 1 times 9 is, let's do -1 times -9 is going to give me 9. And then 3 times 1 is going to give me 3, which is going to simplify to 3. So right now I have -2 is equal to 3 plus b. Subtract 3 from both sides, and I get -5 is equal to b. So now I can reconstruct this entire thing. I'm going to do it in a whole new color. Don't have a color set to that key. Don't want to use white because we're using a white background. So in orange, my final answer is going to be y equals -1/3, because that's the slope we determined we needed right here. And then we're going to have our independent variable. And then our b is -5. So this is written as plus b. If I do plus -5, I'm just really doing -5. So my final answer is y equals -1/3 x minus 5. Put a box around it, and that's how I know that is your answer. Circles around your intermediate answers, and then a box around your final answer. So that's how we do it. That's the lesson for today. I'm looking forward to seeing it presented on Monday and Tuesday in class. And I will stop talking now. Hopefully I shut the video off.